Yeah, good afternoon, dear students. Welcome to Data Structures and Algorithms class. Today we are moving on to Module 2. Module 1 notes is almost ready. So since I have given assignment, there is a time to submit the assignment till tomorrow. So after tomorrow's assignment time is over, I'll be giving the notes. Right. Well, the class agenda today we'll be starting our module 2. In module 2, we'll be talking on algorithms and its importance and different ways of representing algorithms. And also, finally, we touch on the examples of algorithms. So this I have taken from your textbook. The contents I have taken from the textbook, chapter 3. Hope you all have the textbook, right? So anyhow, I'm scanning each chapter, the textbook chapters. Very shortly, I'll be giving the textbook in the form of ebook. Very shortly, right? So coming on to today's class, introduction to algorithms. Normally, algorithms are first step before you write any program. It is a informal way of writing the program. So from the last two chapters in the module 1, we learned the basics of C programming language and its various program constructs. The program constructs like variables, identifiers, functions, loops, conditional statements, switching statements, pointers, structures, unions. So we discussed. And in this chapter, we will focus on one of the main starting point to develop programming applications. So that is algorithms. And of course, if you look at the definition of algorithm is a set of instructions that defines the complete solution to a given problem. And of course, the algorithm is written in simple English language for writing the solution steps. Actually, it is not a program. It is only your own way of imagination you'll be writing. And of course, it is quite possible to have multiple algorithmic solutions for some problem. In such cases, performance becomes the sole criteria for choosing a specific solution. So for any problem you take in this world, there are various solutions. Any problem you take, there are various solutions. And in that solution, which is the best solution suited to you, you'll choose. So that is what the same thing algorithm also. For any problem, you have multiple solutions. And in order to choose which is the right solution, what you have to do, you have to check the performance of each algorithm based on the criteria. And that's what, based on the criteria, based on the performance of the algorithm, you will going to choose which algorithm's performance is really good. So that is going to be used. Of course, we can use various asymptotic notations such as big O, big omega for assessing the performance and running time of algorithm. So you can check, you can evaluate, you can consider the performance of an algorithm based on these asymptotic notations. So in this chapter, we'll also get a brief introduction to data structures. And you know very well, data structure is a collection of data and the associated operations. It's a collection of data plus its operations. Some of the commonly used data structures are arrays. If you use an array has a structure. And of course, using array, you can do some operations. Same way, you can create stack. Stack is a type of data structure. And stack can perform some operations. You take next one, queue. Queue is a data structure. Based on queue, you will perform some operations. So like linked list, etc. So these are the things that you should understand. Data structure is nothing but it's a collection of data and its associated operations. So very, very important thing. You should always understand this line. Please note down, those who are writing in a book. Data structure is a collection of data and the associated operation. Same way, algorithm is a set of instructions that defines a complete solution to a given problem. So these 2 points are very, very important points. So you should understand. These 2 points. Next, why we use asymptotic notations? Because there are multiple solutions, multiple algorithms. So which one is best? If you want to decide, you have to represent mathematically using big O and big omega. So those are performance measuring notations. So that also we'll discuss in the upcoming classes. Right. Now, further, when we consider algorithms, and algorithms can be defined as a step-by-step procedure that provides solution to a given problem. Always remember, algorithm will give you step-by-step procedure, and finally it solves the problem. It comprises of a well-defined set of number of steps. Well-defined set of steps. So you cannot say you will get like this. If you do, you will get some solution. No. It should have a specific set of steps. It should have specific set of steps to get finite number of steps to get the solution. Or you can certainly have a specific set of rules that are executed sequentially to obtain the desired solution. So that is a simple thing that you should understand. So this particular point talks about complete definition of algorithm. An algorithm can be defined as a step-by-step procedure that provides solution to a given problem. It comprises of a well-defined set of finite numbers of steps or rules that are executed sequentially to obtain the desired solution. So this is one thing you should never forget. And to understand algorithms in a better way, let us take one simple problem. What is that problem? Identifying the smallest number from a given list of numbers. So you have a list of numbers, an array of numbers. So some set of numbers, I don't know how many numbers are there. So in that set of numbers, in that list of numbers, you have to find the smallest number. So select the first number. So In this case, I'll select the first number. Okay, I'll select the first number. Let me take this first number as, I'll consider this first number as the smallest number. I'll consider the first number as the smallest number so far. And now you create a for loop. For loop will have looping for each statement, will have looping until you have an element in the list. So the loop will continue until the last element. Every time what it will do, it will check and replace the smallest so far number with the list of elements if the later is small. So if the element, whatever the next element that you are finding, so you compare first element with the second element. If the second element is smaller, you replace that as a smaller. So similarly, you compare third, you compare fourth, you compare fifth, you compare sixth, you compare seventh. So until the elements in the list, you will keep on comparing. And if you find the smallest number, that you will replace. Once all the numbers have been compared, the smallest so far number is considered as the smallest number in the list. So this is how you can certainly consider the smallest number. So this is a simple example we can do. Here, according to our definition of algorithm, you see, you have finite number of steps. So you have finite number of steps. So here, look at here, there are only 3 steps. Yes, you have finite number of steps, and it comprises of a well-defined set of finite number of steps and rules to execute sequentially. Yes, one after other. So it will execute, and finally you will get the answer. You'll get the answer. So this is what you call it as an algorithm. An algorithm, you can certainly call it like this. Now, further, in computing terms, an algorithm is described as a little differently. It is defined as hierarchy of steps used for a computational procedure, which usually starts with input values and generates the desired output. While defining an algorithm, you must consider 2 primary factors: the time required to solve the problem and the required memory space. See, look at this particular diagram. In this particular diagram, what you are trying to do, is very simple. So you have the problem. For this problem, you write the algorithm, you design the algorithm. And this algorithm, you will convert it into a program, and you'll store it in the computer. Now, once it is done, you give the input data. And based on this algorithm and input data, the computer will calculate and it will give the output. Yes, this is the process of how exactly any problem can be solved using computer. But there are 2 primary factors that you should always consider. 2 primary factors. One is time, how much time it will going to take, how much this particular algorithm is going to take time, how much time it will take. So how much time it is going to take. Second thing is space, how much space it is going to take. Space in the sense how much memory space it is going to take. So this is what you call it as time complexity and space complexity. Time complexity is nothing but how much time it will take, how much space it will occupy. That is how much memory it is going to use in order to solve a particular problem using this particular algorithm. Say, for example, you have 3 algorithms. Algorithm 1, A1, A2, A3. So all 3 algorithms works fantastic. So they'll give the solution. But if you use algorithm A1, you will get some different time, A2 some different time, A3 some different time. So out of these 3 different time, which is the fastest that you will choose? Suppose A2 is your fastest algorithm, then you'll certainly consider A2 algorithm. Algorithm 2. So it's just like, if I take you one simple example, if I give you one simple example, you have sorting of numbers. So you have many sorting algorithms. Yeah, somebody, you want to ask something?
One of my friends is in the waiting room, sir. Can you let him in?
Yeah, I have already. Oh, sorry. There are so many students. You all admit all. Sorry. I've already set auto admit. Auto admit feature I have already enabled. Yeah, it is already running. Okay. Okay, it is. They have admitted. Thank you. Thank you.
Okay, sir. Thank you.
So I was just talking about the problem and algorithms. Yeah, there are multiple algorithms. For example, if you take sorting of numbers is my problem. And when I have sorting of numbers, I have so many sorting algorithms. Bubble sort is one type of sorting. Uh, merge sort. I think somebody, they have come almost. Merge sort, bubble sort, merge sort, tree sort, quick sort. There are so many algorithms. Same, they all do sorting only. Sorting only. So, out of which bubble sort has different time, quick sort has different time, merge sort has different time, and uh, the tree sort is having different time. So there are so many sort, but every sort solution will give you the same output. But which one you will choose? You'll choose always the quick sort because it is the fastest. That's why its name quick sort. So it is just like that. And here also I have one more example. For instance, if an algorithm takes I hours to solve a problem, then it is of no use. So similarly, if an algorithm requires gigabytes of memory, then also it is not considered an ideal algorithm. So algorithm should take less time, less space. Of course, today people are not worried much about space. Even if your program takes more space, they may not object. But time is very important. So the algorithm should be very quick enough to adapt. So that is the one very important thing. And of course, how exactly these algorithms are being used in the figure, this particular figure is illustrating. So for any problem, algorithms plays a very important role. It converts your input into right output. So that is one thing that should always understand. Now, an algorithm solves only a single problem at a time. However, some algorithms can be solved using multiple algorithms. So, normally for a solution, there are multiple solutions. For a problem, there are multiple solutions from different algorithms. Of course, the benefit of using multiple algorithms to solve the same problem is purely situational. Of course, situational in the sense, I think they are admitting, yeah, nobody is in waiting room. Right. Situational. For particular situation, some X situation, maybe algorithm A1 may work. For situation Y, algorithm A2 may work. Of course, that is also correct way of analysis. So one algorithm could be more efficient for a particular set of inputs or for a specific variation of the problem, while another algorithm could be more efficient for some different set of inputs or for some different variations of the problem. The use of multiple algorithms is more evident while solving the sorting problem. I was just mentioning in the previous slide also. One sorting algorithm could be efficient for sorting large collection of integers, while another sorting algorithm is more efficient for solving large collection of strings. Thus, in this case, the choice of a particular algorithm is solely dependent upon the different type of data that you are going to give as input. Very important. So, algorithm A1 works excellent fast on integers. The same A1 algorithm may not perform the same performance when it is working with strings. So A2 is another algorithm that may work faster with respect to string. So it is situational. So it is situational, that is solely depending on the type of input that you are giving. So that is one wonderful thing that you should always note. Even though algorithms perform differently at different times, of course, it is totally dependent on the time. It is totally dependent on the time. Next, characteristics of an algorithm. See, why I am giving all these in point wise, because in the examination you have to write in point wise only. In point wise only. So normally they'll ask for 7 marks. What are the key characteristics of an algorithm? So you have to write all 7. So each point will have 1 mark. If you write all 7 points, 7 marks. It's just like that. And the same thing I can ask you in the assignment also. Probably next week I may give the same assignment. So you need to understand and write. Of course, an algorithm must comprise of a finite number of steps. It is the first characteristic. It should be very finite number of steps, very specific number of steps. It should have 0 or more valid and clear defined input values. So algorithm should have at least 1 or of course more, and sometimes algorithms may not require any input at all. So it may take the data already. Okay. And the third point, it should be able to generate at least one single valid output based on input, valid input. So that is very, very important. Fourth point, it must be definite. That is, each instruction in the algorithm should be clear about what it is doing. It is clear about what it is doing. It must be definite. Fifth point, it should be correct. That is, it should be able to perform the desired task of the generating correct output from the given input. So from your given input, it should give the correct output. So algorithm should be accurate enough. And there should not be any ambiguity regarding the order of execution of the algorithms in terms of steps. Steps should be very clear. Steps should be very clear and should able to execute it with absolute clarity. There should not be any ambiguity regarding execution, order of execution of the algorithm. The last seventh characteristics is it should be able to terminate on its own. That is, it should not go into an infinite loop. So algorithm, as you start, after executing all the steps, it should terminate. If it does not terminate, then that is not a good algorithm. It should not go into an infinite solution. So that is one very important thing you should always understand. Now, how do you represent this algorithm? Is there any specific way in which you can write this algorithm? Of course, you can represent an algorithm in a number of ways, right from English language phrases to graphical representation. Yes, you can write algorithm in graphical form, that is flowchart. What do you call it as flowchart? Or in the English language itself, you can write it, which you call it as a pseudocode, or you can write it step by step. You can call it as the general algorithm. However, such representations are mainly useful when the algorithm is simple and small. So graphical representation, that is flowchart, is very much useful when it is simple and small. Another way of representing an algorithm is pseudocode. So one we have seen, it is the flowchart. The next one is a pseudocode. Pseudocode is again, it's an algorithm, is a formal representation of algorithm that provide a complete outline of the program. It looks as similar as a program, so that the programmers can easily understand it and transform it into a program using the programming language syntaxes. So they can easily do it. So pseudocode is an algorithm which is very similar to your programming syntax. The structure and syntax of pseudocode is quite similar to any typical programming language construct. Thus, it's easy to transform it into a program. Since there are no tight syntactical constraints associated with developing a pseudocode algorithm, the programmer has the liberty to focus only on getting the solution logic right. So here, the programmer will mainly concentrate in the pseudocode, the solution logic. What is the exact technique, logic he's using in order to solve this particular problem? That is what he's targeting is all about. So that is what you represent. You can represent algorithm either in pseudocode or in flowchart. Flowchart becomes very efficient when it is simple and small, but pseudocode is really helping programmers in order to transform your program pseudocode into a program. So it is very useful thing. And further, while representing an algorithm in pseudocode form, you must use certain conventions. Normally, what algorithms we write in our course, this particular course, in this particular chapter or module, we should use these following conventions. Conventions in the sense following rules. So why we have to do? Because this helps an easy understanding of algorithm, and following are some of the general conventions that are followed while writing a pseudocode. So definitely there will be a question, theoretical question. What are the general conventions that are to be followed while writing a pseudocode? They'll ask this question in the examination. So you have to write these 10 points. 6 points are written here. 4 points I'll explain in the next slide. The first point, provide a valid name for algorithm. So algorithm will have a name written using pseudocode. The entire algorithm is representing some solution. That solution, entire algorithm, you will have name. It's just like entire program, you'll have a name of the program. Just like that, name of the solution, name of the pseudocode, name of the algorithm is required and it should be valid. That's the first thing. Second one, for each line of instruction, specify the line number. Line number is very, very important while you write the pseudocode. Always begin an identifier name with English alphabet. Fourth point, it is not necessary to explicitly specify the data types of the variables. Of course, variable data types, it is not compulsory. And always, follow the very good program format. Indentation. What is indentation? Very simple. You write the first statement, second statement in the same level. If the next statement is associated with this, you write a little bit tab, and you write tab, you write tab, you write, and next statement, it is like this. So it is understood. If this is true, then these three statements are going to execute. If this is false, then these three statements are executing. So it is just like that. You write proper indentation with the block structure appropriately so that the readability of the program enhances. And use read and write instructions to specify the input and output operation respectively. So whenever you're reading data, that is inputting data, you use the term read. Whenever you're writing data or printing the output, you write instruction is important. So you can use read for input and write for the output. So you can see write for output and read for your input. So you can certainly consider these things while writing the algorithm. So these are the 6 steps. Seventh point. If you are using if statement or if else statement, so you must always have end if. There is one extra word that you should use that indicates end of the if statement. End if is to be used as a special construct when you are writing pseudocode. So look at this example. In this example, if you are using if statement condition and there are some set of statements running, executing, and end if indicates, oh, that is the end of if statement. Same way, if statement and condition expression, if it is true, some set of statements are executed, else some set of statements are executed, and after this you can use end if. So that is going to tell that is the end of if statement. So end if statement is required. End if statement is required whenever you are writing a pseudocode. Whenever you are writing pseudocode. So that is most important thing that you should understand. Now, similarly, whenever you are writing for loop or while loop, same thing you should have. So you should have end for, and end while. If it is a while loop, end while. If it is for loop, for end for loop. And normally in the for loop, you specify the range. For I is equal to 1 to 10. That means I value will change from 1 to 10. So I is equal to 1, I less than 10, I plus plus. So the same statement, it's a syntax you follow in C, but in pseudocode you should write like this. And you should have a block for loop and end for. It should be used at the end of for loop. Same way with the while condition also. And you should use do, while condition, do, and curly braces. And for condition, do, Do is a special keyword that you should have it. Along with this algorithms, pseudocodes. Right. Now, and the representation of logical and relational operators, you can straight away use it as it is. I equal to j, or I less than j, I greater than or equal to j, so that you can represent it in the same format. The 10th point, represent an array or list of elements by specifying the array followed by its index number. Index number is quite necessary. Index number is quite necessary. So what does this index number will do? It will specify what number in the array or in the list you are referring to, and you should use square brackets. It is very similar to the C program construct, that convention that you are using when you're writing algorithm pseudocode. So A of I will represent the ith element of the array A, and that's the 10th convention. And let us look into some of the examples of algorithms that we create using this pseudocode. So I'll take you the first example. Of course, you can take the screenshot. These are all, I have taken it from the exercises, examples given in the textbook. That's why you can see the scan as it is. The first question is, write an algorithm to interchange two numbers. Interchange two numbers. So what you do here, you give a name. First thing, first convention, you should give a name for the algorithm. The name of the algorithm is interchange, and it is taking two variables, x and y. You do not have to specify what data type it is, but they are two identifiers that represent some data. Steps again, step 1, 2, 3, 4, 5, 6 should have. You can see x and y are the values that you are going to feed in, and you begin, and last statement will be end. In between, what you do the operation. You add x and y, store it into x. Next, you remove from x, y, and store the result into y, and the same thing, you remove y from x and you store it in x. So by doing this way, you can exchange or interchange the values of x and y, and this is the logic. These three are the numbers, steps that are being used to exchange the values. Let us take one example. So x is equal to 20. Imagine x is equal to 20, and y is equal to 60. Y is equal to 60. So this is x is equal to 20, and y is 60. Now x is equal to x plus y. So now x value is 20 plus 60, so it becomes 80. In this case, it is 80. Now y is equal to x minus y. X minus y. X value, you know, it is 80. 80 minus y value. Y value is 60. 60. And the result is 20. 20 is going to store in y. So 60 is gone. In place of 60, 20 is stored. So your y becomes 20. Y becomes 20. Now, in the next statement, x is equal to x minus y. X, we know it is 80. 80 as it is, you write, minus y. Minus y. Y value is how much? 20. So you can certainly write 20. 80 minus 20 is 60, is 60. This 60, where you are storing back to x. So 20 gone. In place of 20, your 60. Your 60 is replacing. So your x becomes 60. X becomes 60. So when you write this particular statement, x minus y, so x value is 60 and y value is 20. Yes. Initially it was 20 and 60. Now it has exchanged 60 and 20. So this is the way in which you can write the algorithm. So algorithm, you can write it like this as a pseudocode. Next, you have to calculate the average of 15 numbers. In this case, what do you do? Again, you are giving the name for the algorithm as average, and average avg is the variable that has variable, and sum is the variable that you will going to use. Now begin, average you make it 0, sum you make it 0, and you create a for loop for 15 times, and every time what you do, you read a number and you add it to sum. You read a number, you add it. So all 15 numbers, you read it and you add it to sum. So sum will have total of all 15 numbers. Now average is equal to sum divided by 15. So you will get the average. Finally, you write the average and the end. So this is one simple example which can be used as an algorithm pseudocode to calculate the average of 15 numbers. You can certainly use it. The third example I have taken from the textbook is write an algorithm to sort n numbers. N, you don't know how many, but you can do it. But here also the same. First, you have to give valid name to your algorithm. Valid name is sort, and it will take an array A, and it will take number n numbers. It will take n numbers. Now begin. Read how many numbers. Based on numbers, you create a for loop. For loop from I n to 2, and for j 1 to I minus 1. So it is a bubble sort. If a of j and a of j plus 1 is greater than, then interchange the values. And this process will continue for all j, for all I times for loop. So at the end of this particular algorithm, what happens? All the numbers in the array get sorted, and of course you can print it. Here they are asking you to sort, they are never asking you to print. Of course, if you want to print, you can, before this step 10, you can write the array elements. You can print the array elements, so that you can do it. So I have taken it from the textbook as it is. So these are the three examples that were given in the textbook. Very, very important. And in the examination also, if you read whatever it is given in the textbook, that is sufficient. And whatever the review exercises that are given at the end of each chapter, you have to solve it. So that is sufficient. That is sufficient. And I think I have come to the end of the class. So in the next class, we'll be talking about the second part, these asymptotic notations. What is asymptotic notations are used for? To check the efficiency of an algorithm. To analyze the efficiency of an algorithm, asymptotic notations are being used. So that's all for today's class. Today's class recording will be available in this particular website, and also from tomorrow 5 p.m. onwards, the notes for module 1 and the textbook for module 1 chapters are available in this particular website. So do attend classes regularly. Don't miss the classes. Please type in your USN in the chat box for the sake of attendance. Thank you. Thank you, one and all. Have a wonderful day.